So I want to come back to cost because I think that folks who would be watching this video or who've been exposed to VAST, I would imagine there's a little bit of skepticism around, have you guys actually cracked the code for the all-flash data center?
Sure. So Renan talked a lot about this disaggregated and shared everything architecture that can be built using modern technologies. And so what we've done is we've pioneered a number of new algorithms on top of this new type of cluster architecture that essentially allow us to build a series of compounding factors that ultimately all multiply against each other to deliver an unprecedented level of storage savings. And so it starts with our adoption of hyperscale flash. And as time goes on, we'll adopt future generations of flash, but it starts by having our own distributed data placement engine that sits on top of these devices. And this next generation flash model ultimately allows us to shape writes as they go into low-cost QLC drives. And what we've achieved from that is 20 times the longevity than what the drive manufacturers originally expected from these devices. And so the first thing that we've done is we've basically started from the basis of a very low cost of goods. QLC flash is hyperscale grade flash. The second thing that we've done is we've gotten 10 years of longevity out of these devices, which, if you think about it, it avoids at least one refresh cycle that customers would have to make with other either hard drive or even flash-based technologies. The third thing that we've done is we've pioneered a new erasure code. A new erasure code that's global in nature. We write across all the devices within a cluster. We can do that because of disaggregated and shared everything principles. And what we've solved for essentially is the problem of long rebuilds that happen as you build wide write stripes. And what we've done is we've dramatically shrunk the time to rebuild a lost block or a lost drive. And we've also increased the number of redundancies that you have in a RAID stripe as compared to conventional error correction algorithms. The final thing that we did is implemented a new global data reduction algorithm. We call this similarity-based data reduction. And this new similarity reduction allows us to look across all the blocks within a distributed storage system and find patterns within just as little as 2 bytes. So it combines the best of both deduplication and compression. It avoids the worst of both of those approaches. And what we're finding is that even as people store compressed or even encrypted data into our system, we're finding opportunities to further reduce data down. And so when you combine that data reduction on top of low overhead QLC flash, what you get is something that you can keep on the floor for 10 years at roughly the cost of a hybrid or hard drive based storage system.
Awesome. Well, Jeff, we're going to leave it there. Thank you for joining in this video series. Super illuminating.